Hi guys, a couple decide to have 3 children. Now, the question is, how do we serve up that sample space? Because it can be rather complex and sophisticated, because you could have a boy, then a boy, then a boy, or perhaps a boy, a girl, and then a boy again, or maybe a girl and a boy. Kind of gets complicated. So how do we put it together? Well, you guessed it, that's right. We use probability trees. I'm going to put one together now for this particular sample space, and we'll go through it in more detail. Welcome back. Yes, this couple decide to have 3 kids, and the chance of getting a boy or a girl obviously is equally likely. It's half, or 50%, one chance in 2. And as we've shown here in the diagram, this is going to be the first child. It's either a boy or a girl. Then the second child could be any one of these possibilities along here. And then the third child could be any one of these possibilities. And all the possible outcomes, the sample space, is summed up all across here. Because there are 3 children, there's going to be 8 possible outcomes. And we're going to pick the favorable ones. They come up from the question, because here's the clue here. The question asks for, what's the probability of getting 2 girls and 1 boy? Now, it doesn't matter what order they come in. So all we're looking for is 2 girls and 1 boy in any particular sequence. So remember, when we go along the branches like this, we multiply. That's when we say and. And when we go vertically down with those particular outcomes, that's where we use the or concept. That's where we add all together. So we have the and multiply, and the or and plus across there. So let's get into the first part again. 2 girls, 1 boy. Let's mark them out. 2 girls, 1 boy. Let's have a look here on the possible outcomes. 2 girls, 1 boy, right over there. 2 girls, 1 boy, right over here also. And 2 girls, 1 boy, right over here. Now, you can do it this way. You can actually look at those favorable outcomes, which is 1, 2, 3. And that'll be 3 over all the sample space along here, which is 8. And that works pretty good because they're all equally likely, all the events, and they're independent, meaning one doesn't affect the other. So let's write up the sample space here and all the probabilities. So the best way to put it together would be, it's going to be the probability of the first possibility, which is boy, girl, girl, or the probability of girl, boy, girl, or the probability of girl, girl, and boy. Now remember, when we use the word or, we add. So I'm going to replace that with a plus right there. So let's multiply across a boy and a girl and a girl. Well, what's the possibility of getting a boy? 1 chance in 2. What's the possibility of getting a girl? 1 chance in 2. They're each 50% each. So we'll go 1/2 and 1/2 times 1/2. So all of them will be a half times a half times a half, each one of these. Now a half times a half times a half is 1/8. So it'll be 1/8. There's the plus another 1/8 plus the last 1/8. That's the last 1/8 right over there. Adding them all together is going to give us the answer, which equals okay, let's go to the next part. We're talking part B. What's the probability of getting three boys or girls of the same sex? So that means we want boy, 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 or girl, girl, girl. So let's mark them out over here. First, let me take these down. So 3 of a kind, in other words. So we're looking at girl, 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 or boy, boy, boy. So let's write up the sample space for that. That'll be or, girl, girl, girl. And here's the or again, where we can just put a plus right over there. Okay, that's going to be a half times a half times a half, and similarly the same with the girls. So let's write that down here. Just like before, and that's going to give us an eighth for each one, so it'll be 1/8 and 1/8. Adding them together will give us 2/8, and we can simplify that for the final answer, simplifying 2/8, and the answer is 1/4.